Hello, my lovely students. This is going to be the last video that I create before spring break. So we have the Unit 2 Quiz 1 review that was given to you today as your online assignment. And I'm going to be working through each of the problems to hopefully give you some helpful hints and things that you should know for your quiz that you're going to be taking on Friday, which is tomorrow. Okay, so anyway, starting with problem number 1 here, the directions say factor the polynomial completely. So when we are factoring, step number 1, always look for the greatest common factor that can be factored out of any of the numbers or any of the variables. So let me get my color here. So if I look at my 3 terms, 20, 55, and 30 can all be divided by 5. So, or they all have a factor of 5 in them. So I can factor out a 5. They also all have x's. So I can factor out an x to the third. Now, when you're factoring out 5x to the third, you're dividing each term by that 5x to the third. So the 20 divided by 5 is 4. X to the fifth divided by x to the third is x squared. Then take your negative 55 divided by 5, and you get negative 11. X to the fourth divided by x to the third is x. 30 divided by 5 is 6. And then the x to the third was factored out, so there should be no more x's with this 6. Also notice you have 3 terms to begin with. You have 3 terms in the parentheses. And if we were to multiply the 5x to the third back into each of these terms, we would get what we started with. Okay, so now that we've factored out the 5x to the third, we have to focus on this trinomial, 4x squared minus 11x plus 6. So this is not a basic trinomial because the 4 in front is not 1. So we are going to have to use the AC method, which means that I'm going to have to take these 3 terms and turn them into 4. So it's kind of like unfoiling. The first term stays the same, and the last term stays the same. When I multiply my A, which is 4, times my C, which is 6, together, I get positive 24 for my AC value. So if I think of the factors of 24, I have 1 and 24, 2 and 12, 3 and 8, 4 and 6. So using the question that I like to ask is, again, looking for 2 numbers that multiply together to equal 24, but add up to 11, because that's what I have in the middle here. So if I look at my numbers that multiply together to equal 24, 3 and 8 will add up to 11. Now you want to be careful. You want them to add up to a negative 11. So negative 3x and negative 8x will then give us our middle terms that combine to give us that negative 11x in the first place. Also, whenever your C value is positive, you know that these signs should be the same. So just some other factoring tricks. So now we are going to factor by grouping. Also, don't forget that 5x to the third is one of the factors of the original polynomial, which is why it keeps coming down. It does not disappear. All right, so now we're going to factor by grouping. So if I separate my first 2 terms from my second 2 terms, focusing on just those first 2 terms, what can I factor out? Well, just an x. And then when I factor out the x from both of those terms, I'll still have a 4x minus 3. My next 2 terms, I'm going to factor out the negative and a 2. So when I'm factoring out negative 2, I'm dividing each of these terms by that negative 2. So negative 8 divided by negative 2 is a positive 4. Still have the x with it. And then 6 divided by negative 2 is negative 3. So again, you can see that these binomials match as they should. So now factor out the x for x minus 3, and then put the x minus 2 in the other parentheses. And again, if we were to multiply these two binomials back together and simplify, we would get 4x squared minus 11x plus 6. But then again, don't forget this 5x to the third is one of the factors, so that's part of your answer. So your answer here, all these factors, if we were to multiply them back together, should equal the original polynomial. All right, so that concludes problem number 1. Moving on now to problem number 2. So in this problem, we have the same setup as problem number 1. The difference, though, is that we have this equals 0. So we're finding all of the solutions. And if you know from the fundamental theorem of algebra, since the degree is 6, there should be 6 solutions. So we need to find all 6 of those solutions. Change my color here. So with polynomial equations, you do always want the equation to equal 0. So when I get to numbers 4 and 6, I am going to have to move the terms over to get them equal, get the equation equal to 0. But this one already is equal to 0, which is nice. So once again, I'm going to look for the greatest common factor between 12, 28, and 40. So I know that they can all be divided by 2. 38 divided by 2 is 19. And 19 is a prime number, which means 2 is the largest number that I can divide or factor out of all 3 of those numbers, coefficients. The smallest or the most amount of x's that we can take out is x to the 4th. So all of them have a factor of x to the 4th in them, and they all have a factor of 2 in them. So 2x to the 4th is my greatest common factor. So now, if I divide all these terms by 2x to the 4th, I'm going to get 6x squared minus 19x to the 1st, and then minus 20. Because 12 divided by 2 is 6, negative 28 divided by 2 is negative 19, negative 40 divided by 2 is negative 20. And we factored out the x to the 4th. Again, if you were to multiply this back together, it would equal what you started with. All right, so let's continue to factor. So this trinomial here, just like the one in problem number 1, is going to have to be factored with the AC method. That means you're going to turn the 3 terms into 4. So 6x squared comes down. Your first term and your last term stay the same. Oops, going back, or no, that one. I was just thinking I forgot the equal 0 in problem number 1, but problem number 1 is just factoring. Problem number 2 is solving. There is a difference between the two. So for this problem, we do want to maintain that equal 0. And don't forget this 2x to the 4th that we're bringing down. All right, so now again, we're going to use that AC method. So I'm going to multiply 6 times negative 20, which gives me an AC value of negative 120. So 120 is kind of a big number. So I might not want to list every single factor of 120, but I might want to start with maybe 5. 5 goes into 120, let's see, 24 times. And look at that, 5 and 24, the difference, if I were to subtract 24 minus 5, I would get 19. And because your AC and your C are negative, that means the signs here and here in your 2 terms in the middle have to be different. So if I had a negative 24 and a positive 5, that would equal that negative 19 there in the middle. So again, I just chose 5 because it ends in a 0, and I know that 5 and 10 both go into 120, so that was kind of lucky there. Anyway, all right, so negative 24x and positive 5x will be our middle terms that give us that negative 19x. So now, once again, we're going to decisions, green. Okay, so now we're going to factor by grouping. Take out the greatest common factor from the first two terms here, which will be 6 and x. So if I factor out 6 and x, I will now have x minus 4. So again, I'm dividing each of these terms by 6x. And if I multiplied it back together, it would equal what I started with. The next two terms, I can factor out a positive 5. So again, make sure you bring that sign down. And then 5 goes into both of those. So when I divide 5 out of both of those terms, I'm going to get x minus 4. Okay, so I'm going to put that in brackets because I still have this 2x to the 4th, and this equals 0. All right, so keep on going. So now I'm going to factor out the binomial x minus 4. I'll go back to my blue. So this x minus 4 gets factored out. So again, think of this as one term, think of this as one term. What do both terms have in common? The x minus 4. So we factor it out. So it kind of goes out there. And then the 6x plus 5 is what's left in parentheses. So kind of like we said over here, when there's 3 terms here, when there's 3 terms here, you're going to get 3 terms here. Well, if you think of this as 2 terms, you're going to be left with 2 terms because the x minus 4 is factored out. Anyway, hope that made sense. So the 2x to the 4th, now I am going to kind of break this down into 2x. Well, not yet. I'll do it in the next step. Okay, so this is 2x to the 4th. So if all I were doing was factoring, this would be factored completely. However, I'm solving, and there are 6 solutions for me to find. So this 2x to the 4th, if I were to factor, that has 4 factors of x. So I could factor this into 2x times x times x times x. And that 2, I could even factor that out also. That 2 is not going to have any effect on my solutions. But every one of these x's, if I set them equal to 0, would give me a solution of 0. So I would have to state that x equals 0 with a multiplicity of 4. So that represents 4 of the 6 solutions that I'm trying to find. So the next factor that we have is x minus 4. So if I take the x minus 4, set that equal to 0, add 4, I get x equals 4. So that's my 5th solution. And then take the 6x plus 5, set that one equal to 0, subtract your 5, you get 6x equals negative 5, divide by 6 and x equals negative 5/6, and that is your last and final answer. So 4 solutions of 0, 1 solution of 4, and 1 solution of negative 5/6. All right, moving on to problem 3. So in problem 3, we are just factoring. We are not solving. So if we are factoring, we do have a trinomial with a leading coefficient of 1. So I'm going to do this the way I'm going to do it, the way I usually do it, and that's just to go right to my 2 binomials. But I will also show the alternative method of using the AC method. It takes longer, but a lot of students I see are doing that in their assignments. So I will show both ways for you. All right, so since I have an x to the 4th here and I have an x squared here, I need these 2 terms to be x squared. So x squared times that x squared will equal the x to the 4th. But as far as finding my 2 numbers that multiply together equal 32, but have to add up to 18, I would, again, list my factors of 32, 1 and 32, 2 and 16. Oh, 2 and 16, those add up to 18. They need to multiply together equal a positive, so that tells me the signs have to be the same here and here, but they have to give me a negative 18 in the middle, which means that both of them have to be negative. So negative 2 and negative 16. Now, if you look at this polynomial, the x squared minus 2 is not a difference of squares because 2 is not a perfect square. So since we are just factoring with real numbers, or we are not factoring with irrational numbers, so we're going to just leave that x squared minus 2 alone. However, the x squared minus 16 is a difference of squares, so that can be factored again. The x squared factors into x and x, the 16 factors into 4 and 4, but your signs must be opposite, 1 plus and 1 minus, so that when you multiply them together, you get a negative 16, and if you added them together, it would be 0, which is why there's no middle term in the first place. All right, so this is now factored completely. So if you're just factoring completely, you are not solving. You are not getting a solution for x. You're just factoring as much as you can. The next one is the one that we are solving. So we are solving. And if we look at this polynomial, the degree is 4, so there should be 4 solutions that we're looking for. With polynomial equations and quadratic equations, when you have two different terms that have a variable in them and they're not like terms, you do want to set the equation equal to 0. So x to the 4th plus 4x squared. And then when you subtract the 5, it will be minus 5 equals 0. So we're going to factor this now, just like the other one, into our two sets of binomials. Your x to the 4th factors into x and x, or I'm sorry, not x and x, because it's x to the 4th, and this middle one is x squared. You need these to be x squareds. All right, so once again, I'm trying to find two numbers that multiply together to equal 5, but this time, because it's negative, I think of numbers that have to have a difference of 4. So 1 and 5 are the only factors of 5, and they do have a difference of 4. Now we want them to multiply together to equal a negative, which means your signs must be different. But the larger one is going to have to be positive in order to get a positive 4 in the middle. So negative 1 plus 5 does equal a positive 4. Negative 1 times 5 equals a negative 5. All right, now that it is factored, we could continue factoring this x squared minus 1 into x plus 1 and x minus 1, because that is a difference of two squares. 1 is a perfect everything. It's a perfect square. It's a perfect cube. So 1's a nice number. But this x squared plus 5 cannot be factored anymore. All right, so now that I have factored it completely, I can then go to solving it, because in problem 4, we have an equation. It does equal 0. There are 4 solutions. So if I set my x plus 1 equal to 0, I get a solution of negative 1. If I take the x minus 1 and set that equal to 0, I get a solution of 1. But this x squared plus 5, when I set that equal to 0, moving the 5 over will make that negative 5. Now I need to take the square root of both sides. Because it's an even root, I will have two solutions, the positive and the negative. But the square root of negative 5, I'm going to factor into a square root of negative 1 and a square root of 5. The square root of negative 1 is where I get my I from. And then the square root of 5 cannot be simplified. So you can write the answer as square root of positive and negative square root of 5i. Or you could state that x equals positive and negative I square root of 5. It doesn't matter whether you put the I before the square root or after the square root, as long as it's not in the square root. All right, so we do have 4 solutions now: negative 1, positive square root of 5i, and a negative square root of 5i. All right, so I did say that I was going to show you how to factor these with the AC method. So bear with me if you if you're good at using if you're doing fine with just using the basic trinomial method, then you can probably go forward the video a little bit. So I'm going to restart this over again, because again, I know that students factor these with the AC method, and they take the 3 terms and turn them into 4. So x to the 4th would stay the same, 32 would stay the same. You're still going to look for 2 numbers that multiply together to equal 2 that add up to 18. So just like before, we're going to use those same numbers that we did earlier, -2 and -16. But be careful, you have an x squared in the middle, which means these have to have x squareds with them. So if you don't put x squareds there, then it's not going to factor out properly. Now we'll factor by grouping, factor out the x squared from the first 2 terms, leaving you with x squared minus 2, then factor out a -16 from the 3rd and 4th term, which gives you, again, x squared minus 2. So then factor the x squared minus 2 out, because this is, think of that as one term, think of that as one term, factor out the x squared minus 2, and then the x squared minus 16 goes together. And then the x squared minus 16 then, of course, can be factored again into x plus 4, x minus 4, and don't forget you have the x squared minus 2 that was in front. So we still have the same solution as we had earlier, so they are the same, but there's just more steps involved. And you can do the same thing with problem number 4 here. After you set the equation equal to 0, you can go from 3 terms to 4 and then factor by grouping, but you would still get the same 2 binomials here of x squared minus 1 and x squared plus 5. Okay, so moving now down to problem number 5. So in problem number 5, we have 4 terms, and we're just factoring completely. There is no equal sign. We are not solving for x. So since there are 4 terms, and there are not any like terms in all 4 terms, there is no greatest common factor of the whole polynomial. So we're going to factor by grouping right away. I'm going to factor out the x to the 3rd, which then leaves me with x minus 1. And then the negative, the 125, they both have 125, but I also want to factor out this negative, oops, not 125, and that then will again give me x minus 1 to match with this x minus 1. So once again, what they have in common, the x minus 1, and then the x to the 3rd minus 125 goes in parentheses. But you are not done here. X to the 3rd is a perfect cube. So is 125. So we're going to factor this it's a difference of cubes. The x minus 1, we're not going to do anything, is just going to come down. We're done factoring that part. But the difference of cubes will factor into a binomial and a trinomial. So the cubed root of x to the 3rd is x. The cubed root of 125 is 5. Then you take your first term x and square it. Then multiply the x and 5 together. That goes in the middle. And then take your 5 and square it and put it here. Your signs, we use the acronym SOAP for same. So this sign here stays the same. Then the next one is opposite. And the last one is always positive. This x squared plus 5x plus 25 cannot be factored anymore, so do not try to factor it. So we have succeeded in factoring this completely. Number 6, now we are solving. Back to this. So find all solutions to the polynomial equation. So again, if I look at my degree, I've got 4 as the highest degree, so there should be 4 solutions. But before I find those solutions, I do have to get this equation equal to 0. So this negative 64x and negative 448 are going to go to the other side. And when they move from the right side of the equation to the left, they're going to change signs. So this negative 64x becomes positive. The negative 448 becomes positive 448. Now, if you did have a positive number over here, When you move it to the left, it would become negative. So be careful when you're moving terms from one side to the other. All right, so just like the last one, we have 4 terms going on here. So we are going to factor this by grouping. Out of the first 2 terms, I'm going to factor out x to the third, which leaves me with x plus 7. And I'm guessing I'm going to have to factor out this positive 64. So I'll still have an x there because 64 times x is the 64x. And if I divide 448 by 64, I do get 7. So now again, think of this as one term. Think of this as one term. They both have the x plus 7 in common, which means we're going to factor it out right here and put the x to the third plus 64 in parentheses. So just like the last problem, we had a difference of cubes. Well, this time we have a sum of cubes because we have a plus sign in between the 2 perfect cubes. 64 is a perfect cube. I know it's a perfect square also, but we do use 64 a lot. 64 is, the cube root of 64 is 4. All right, we are solving this, so we do have to put the equal 0 here. We're going to continue to factor the x plus 7, bring down, but keep in mind that your x to the third plus 64 factors into a binomial and a trinomial. The cubed root of x to the third is x. The cubed root of 64 is 4. Take the x and square it and put it here. Then multiply the 4 and the x and put it in the middle. Then take the 4 and square it, put it at the end. Then signs are the same, so this one is the same. The next one will be opposite, so if this was positive, this one's going to be minus. And the last one is always positive or always plus. All right, so now when we solve, if we set the x plus 7 equal to 0 and subtract 7, we'll get a solution of negative 7. If we take the x plus 4, make that equal to 0, subtract 4, you get x equals negative 4. So those are 2 of our 4 solutions. Those are the easy ones. Now we get to the hard one. This cannot be factored. And if it cannot be factored, then you must use the quadratic formula. So quadratic formula states that x equals the opposite of b. So just now I want to use a different color. So a is 1, b is negative 4, c is 16 in our formula. So the opposite of negative 4 is positive 4, plus or minus the square root of negative 4 squared is 16 minus 4. Multiply the a and the c together. 1 times 16 is 16. And that all gets divided by 2 times a. A is 1 times 2 is 2. So now over here, I'm going to take my 4 over 2 plus or minus something over 2. So to get this something, the numerator there, I do have to take this square root and simplify it off to the side. So 16 minus 4 times 16 is 64. When I subtract that, I get a negative 48. Since it's a negative number under there, I'm going to factor out the negative 1. And then the largest perfect square that's a factor of 48 is 16. And the other factor is 3. Since 16 is a perfect square, take the square root of it, you get 4. The square root of negative 1 is I. The square root of 3 cannot be simplified. So when you put that all together and bring it back up here, you'll have 4i square root of 3, or 4 square root of 3 with the I at the end. Then you want to reduce each term individually. So the 4 over 2 becomes 2. And then this 4 over 2 is also 2i square root of 3. Now keep in mind this does represent 2 solutions. And if you wanted to, you could write them separately as 2 plus 2. And this time I'm going to put the I at the end just for fun. So 2 squared 3i, and x also equals 2 minus 2 square root of 3i. So that's another way of writing it. So these are the same answer. All right, moving on. Now, on your assignment yesterday, I forgot to put a couple of problems that you kind of need to know for your quiz or that we've covered in these first few lessons. So I added them to this document. So those of you who are watching the video, you will have a bonus because you're getting a preview of these problems or good review of these problems. So anyway, number 7, use the factor theorem to determine if the binomial is a factor of the polynomial and explain why or why not. So here is our polynomial, here is our binomial. So basically we want to divide the polynomial by the binomial x plus 2. So if we're dividing by this binomial, we want to substitute -2 into our synthetic division. So the factor theorem basically states that if you divide the polynomial by about that binomial and you get a remainder of 0, then it is a factor of the polynomial. All right, so when you are using synthetic division, don't forget to look for missing terms. So actually, I should probably erase this. Let's rewrite so we're basically taking x to the 5th, which has a coefficient of 1, plus 2x to the 4th. There is not an x to the 3rd term, so I'm going to put plus 0x to the 3rd. And there is a x squared, 2x squared, plus there's no x term, so 0x plus 6. And we're dividing that whole thing by the binomial x plus 2. So with synthetic division, if you're dividing by x plus 2, the number that you're putting in the corner is -2. So it's the opposite of what is in the binomial. Then we take our coefficients, and don't forget about those zeros, 1, 2, 0, 2, 0, 6. And bring down some space there and now we basically work through our synthetic division to see if it equals 0. Carry down the 1, multiply, you get -2, add, we get 0. 0 times anything is 0 again. 0 plus 0 is 0. 0 times -2 is still 0. 2 plus, so add them. So we're adding basically these things together. 2 plus 0 is 2. Multiply the 2 times the -2 and you get -4. Add 0 and -4, you get -4. Multiply -2 times -4, you get 8, which gives us 14. So the remainder is not 0, which means that x plus 2, so you would, to state your answer, you would say no, x plus 2 is not a factor of the polynomial because, I'll use my abbreviation B/C, the remainder does not equal 0. Or you could also say something like, because it was p of x up here, so you could say p of -2 does not equal 0. So that's another way of stating that the remainder does not equal 0. So that whole thing is basically my answer to the question, and it explains why and or why not. All right, so the next problem is similar, but this time it says to, let me change my color here. It says to use the factor theorem to show that the binomial is a factor of the polynomial. So this is telling us now it should equal 0. Then factor it completely. So we are going to be factoring this polynomial completely. So once again, we want to take our polynomial x to the 4th, and I'm going to rewrite it with any missing terms. So if you look, you're missing the x to the 3rd term again. So put plus 0 x to the 3rd, and then minus 57x squared. We do have an x to the 1st, plus 56x, but we are missing a constant. So we do have to put plus 0 for the constant. And we are dividing this now by x minus 1. So that's what we have to do with the factor theorem to show that it is a factor of the polynomial. All right, so since we're divided by x minus 1, the number that we're going to put in the corner is positive 1. Your coefficients are 1, 0, negative 57, 56, and 0. So bring this down. All right, so go through the process of synthetic division, carry this down, you get 1, multiply 1, add 1, multiply 1, add negative 56, multiply negative 56, add we get 0, multiply we get 0, add we get 0. So great, that the remainder is 0, which shows that, so that's what we were supposed to do at first, show that the binomial is a factor of the polynomial, which means I should get a remainder of 0. If I do not, then I did something wrong. All right, so, but now we have to go on to our next task, which is factor it completely. So we want the factors to multiply together to equal what we started with. Well, the x minus 1, since we divided that and got a remainder of 0, x minus 1 is one of the factors. So it should be in my list of factors. And then these numbers here will give us the remaining polynomial, keeping in mind that we started with x to the 4th. This 1 will be the coefficient for our x to the 3rd term. And then this one will be our coefficient for x squared. And then the negative 56 will be our coefficient for x. Now we could put a plus 0, but it really is not necessary. All right, so now we're here, which is a little bit confusing because all three of these terms have an x. And if we looked at our polynomial in the beginning, if we would have factored out an x from the beginning, then we would have also had a greatest common factor of x. So even though we didn't do it at the beginning, we can do it here. So x minus 1 on the outside. I'm just going to put the x that I'm factoring out here. And then when I take an x out of each of these terms or divide all of them by x, I get x squared plus 1x minus 56. So now I have a quadratic trinomial that I can factor. It's a basic trinomial. The x squared can factor into x and x. Two numbers that multiply together equal 56, but subtract or have a difference of 1, 7, and 8. Since the 56 is negative, I'm going to have opposite signs. My signs have to be different, but the larger one has to be positive so that I'll get that positive 1 in the middle. And then I'm just going to switch these two factors around because the x I like to put in the front because it's a monomial. So monomials should probably go in front, and then your x minus 1, x minus 7, x plus 8, and all that equals p of x. So this is now factored completely. If you were to multiply these all back together, it would equal the p of x that we started with. All right, so problems 9 and 10 are going to be very quick. I probably didn't even need to put them on here, but just to make sure that you understand the fundamental theorem of algebra states that the number of solutions is the same as the degree. So if we look at this polynomial, the degree is 7, which means there should be 7 solutions. And if we look at the next polynomial, we have a degree of 4, so there will be 4 solutions. All right, that's it for our review. Hopefully you understood everything and you're going to do great on your quiz. No cheating though.